Okay, in a minute, we're going to be doing a favor for the Sacramento Math community. They are a Discord server, which, as I'll say, they are linked in the description. But before we do that, announcements. Real quick too, thank you to everyone international who watches this channel. I think it's something like only 70% of my viewers are in the US. The other 30% are scattered around the world, from Canada to India to Nigeria to Korea, South Korea, obviously. Sad day. And, various other places around the world. I can't think of all of them, but the percentages aren't high for all of them. Like 1% of viewership comes from each of the nations. Canada's the highest. Go Canada, eh? All right, anyways. Next up, the t-shirts. They are getting really close to being finalized and done. This is the t-shirt. This is a large. I'm going to do a print run here really quick. I've already got some being printed right now, but I kind of need to have an idea of how many we're going to need. So to be clear about the t-shirts, what you're actually buying is not a t-shirt. You're supporting my channel. You're offering a donation to support the channel, and in exchange, I'm going to give you a t-shirt. I don't quite know how this all works out as far as taxes and everything else goes. I'm meeting with a tax attorney soon to figure that out. But in the meantime, I want to get a preliminary idea of how many we need. The shirts are actually not that cheap. We made a couple different shirts, one from a different company. I didn't like that one. It was lower quality. The colors don't pop as much as they do on this shirt. So the person making this shirt, the price for it is not as cheap as a normal t-shirt for me to buy. So what we're asking right now is going to be $50 a shirt. Maybe $49.99. I don't know exactly. We'll look at it. Plus shipping and handling. Obviously we have to ship it to you. And that's, I don't know what it's going to cost. Maybe $4.99, $5.99. I don't know what typical shipping and handling costs are. We will go down to UPS and USPS and find out what they do. I don't know about international shipping at this time. I'm sure it's possible. I will look into it. Send inquiries if you're interested in a shirt. Again, this is a large. We will have also medium. To give you an idea, I'm about 6'1", 170, 165. So this a large fits me. I've washed this a couple times. It didn't shrink too much. I've got a little bit of gap here before it's there. It will shrink slightly. The t-shirt itself is also pretty thick for a t-shirt. It seems like it's a pretty good quality fabric on top of the design being a good quality as well. So if you guys are interested in that, you don't have to do an order today, but just send me an email that you are interested in it, so I kind of get an idea of how many to order of each size for the initial printing. So if you can, the beauty of math 13, that's a 13@gmail.com. 13 is my lucky number. I will not explain why at this time. Okay, so that's the price of the shirt. Again, it's not really the shirt though. You're offering a donation to support the channel and its continued improvements and lighting and everything else. And actually past investment. It takes a lot to invest to start a channel, to be honest. So next thing up, I do tutoring, and there are future classes that will be offered. They're not being offered at this time. I don't know what the classes are going to look like. All of that's still being designed. Semi-private tutor means 2 or more people, maybe not a full-size class, but I could pair you up with someone. Some of you have inquired and I think maybe got discouraged at the private tutor rate. I'm not going to give the rates on the video. You will have to email me for those. The rate that I'm asking is just what all the tutor centers in my area charge. To give an idea, the Los Angeles region, it's very high cost of living in California. So taxes, gas, rent, all of those things are just sky high around here. What we pay in rent here, you could probably have a mortgage on $1 million home in Texas. It's or a much bigger home. So anyhow, just to give you an idea of what that's going to be. But if you can't afford the private tutoring, I get it. I totally get it. I've been there before. There is semi-private option or classes down the road. I can put your name on a list and what you're interested in and try to match you up with another student. As soon as I get another student on your level, the semi-private rate is slightly lower. But again, send an email to inquire about that as well. This same email. Okay, so free AMC 8, 10, and Math Counts Prep. Not from me. There's going to be a link in the description. It's done by a channel called Explore Math. To be totally honest, I have no idea Explore Math's ability. I haven't had time to really evaluate his channel or his teaching techniques or anything like that. But I would assume anybody who's making a channel and attempting to teach has some level of competency, and you really can't beat the low price of free, right? So if you, like me, again, I've never had an hour of private tutoring, never attended a class outside of school that I paid any money for, at college besides that. But I mean, I didn't do on the side kind of extracurricular stuff. So if you grew up like that, I had the budget video a while back. Here's another option. It's free. You might as well check it out, right? If you can't afford, a private coach or a private tutor, no problem. Take advantage of free resources. Okay, so that's going to be in the description as well. The person that's offering the classes seems like a nice dude. Met him on one of the Discord servers, I believe. Yes. So, lastly, the AMC 8 Live Solve recap and future live solves. So, AMC 8 Live Solve, I thought it went great overall. I mean, was I disappointed in myself? A little bit, but then I kind of had to rationalize it. There was, 70 some odd people watching, 73, 75, something like that. Several of my family members who've never seen what I do for work. It adds a lot of pressure. It's kind of like you're playing a sport, but you're the only one playing. There's nobody else to watch. And so the pressure is a little bit higher. I made a simple, stupid mistake on, I forget which problem, 14 or something like that. Go watch the live solve if you want to see it. I didn't look at it. It was 40,000 and it was 60,000 and I just assumed it was 50,000. And so I put the dot at like 4250 or 4350, something like that, and got it wrong. Made another error later on, but I didn't answer the question. I skipped it, so it would have counted as a skip, even though you should never skip on the AMC 8. It is what it is. Pulled to 22. I can do better, right? Okay, so future live solves. I think I'm going to be live solving the 2021 February AMC 10A. Another person had asked me what my intent was. Fidget Boss, he's a pretty famous AOPSer, somewhat famous. I don't know who's famous, but he's a pretty smart dude. He inquired about it. I think he might be planning on doing a live solve as well for one of the tests. You might check out his channel. I don't know where it's at. You can find him on AOPS. There's only so many people named Fidget Boss. And he's made some mock tests in the past as well. Dude's pretty smart. If he does a live solve in the future, I would probably check it out if I was you. Anyhow, so 2021 AMC 10A, you might not know, but I saw in the AOPS forums that a letter went out to the teachers that the AMC 10 is moving to November in 2021. So you'll have the one that in February, the normal one, but then the next school year cycle from 2021 to 2022, the test will actually be about the time of the AMC 8 is now. And the AMC 8 is going to move to a different time slot. They haven't pinned it down yet as far as I've seen for those kinds of announcements. So again, medium is probably the majority of students. Small, I don't have them yet. When I have the t-shirts actually ready, the first print, I'm going to get in about 10, probably Friday or Saturday. I'll make a video just about those so that you can see what the sizes look like. I'll hold them up and all that kind of jazz. Let's get started on the SMC. Be back in a moment. All right, these problems are being done, as mentioned earlier, as a favor to the Sacramento math community. They held a competition. I want to say that it was last Saturday, I think. Anyhow, they put it together. They are a Discord server out of, obviously, Sacramento, California. I agreed to do some of their problems for them at their request. I'm going to do 11 through 15 in this video. We'll see about coming back and getting the other ones before or after later on. But I wanted to get at least 5 in just as a favor because they're a good community and they're good people. You can find their Discord server in the channel link. You can also find this competition, which will probably be annual going forward. Inquire at their Discord server. The link to the competition, the questions for it, will be in the video description as well. Let's get started. An equilateral triangle, a square, and a regular hexagon have an area of 36 each. The sum of the squares of the side length of each polygon can be written like this. Again, once you see it can be written as, stop reading. The point you want to focus on is the sum of the squares of the side lengths. Okay? So, equilateral triangle, let's start there. This should be common knowledge. The area of an equilateral triangle that I prefer to remember is s squared root 3 over 4. If you're using half base times height still, dang, you gotta you gotta get on your game. You gotta learn this one, right? Because this is the better formula. So s squared root 3 over 4s for side length. This is one of the only times I like to use s. I don't know why, I just like this formula. Instead of an x here, I like the s. So they're all equal to 36, so you'll multiply by 4, and you'll divide by root 3, and then you're like, oh, now I got a square root? I'm gonna have a fourth root? I don't want to, stop. Just stop. Go back and read what you're looking for. The sum of the squares. This is the square of the side length of the equilateral triangle. So we actually don't want to square root, even though these are both perfect square roots. A really quick note, if you're simplifying or rationalizing a denominator, there's actually a shortcut. If you just divide this 3 into the 36, you will get 12, and then just tack on a root 3. This is going to equal 48 root 3. To illustrate that shortcut, rather than what you learned in school, you don't use it in school because your school wants you to show your work. But in competition math, no one cares, as long as you get it correct. And even then, people probably don't care. Okay, so anyhow, how would it work? Let's say I had 12 over root 2. Just 2 into 12 to get 6 and attach a root 2. What if I had 12 over root 6 then? Just 6 into 12 is 2 root 6. You can explore why this works if you want. What about 18 over root 6? 6 goes into 18, 3, tack on the root 6, 3 root 6. It's just fast, right? It's faster. When you're on a competition and time is of the essence, every second counts. So we're going to continue on from there. I don't want to leave this work up for now. We've got the square of the side length of the equilateral triangle. Now, the square, the side length squared is the area, so you're just going to add that. So we're going to have 48 root 3 plus 36 plus, now we need the regular hexagon. Well, you guys know a regular hexagon is actually 6 equilateral triangles. You don't need to use half apothem times perimeter. No, we use that for like septagons or, I don't know, pentagons or something. And you need to use trig and all kinds of stuff and probably a calculator for most. But for this one, we don't need it. It's just 6 equilateral triangles. And you would know that 6 times, I'll call it x this time, x being the side length of one of those equilateral triangles, which would be the side length of the regular hexagon, then this has to equal 36. Since this is 3 over 2, we're going to reciprocal multiply to get x squared root 3 equals 24. You will divide by root 3. Again, 3 goes into 24. 8 times, tack on a root 3. I'm just using the tactic I taught you a few minutes ago. Add this to get 56 root 3 plus 36. Add 59 plus 3 is 89, plus 6 is 95. And we're on to the next problem. All right, and continuing on with the 2020 SMC Problem 12. Let n equal the sine of pi over 6 cosine of pi over 12. This would be 30 and 15. If you're not quick with the radians, get quick with the radians. Be a good idea. Minus the cosine of 30 times something going on. This looks familiar. It's right here. It's also right there. That's right here. It's kind of a nested function, actually. You could think of it that way and make it more complicated if you want to. The value of n can be expressed as, right, n's equal to this root a minus root b over c. What is this expression? Again, we should stop reading when they tell us it can be expressed as and just find the value of n, and then worry about how it's expressed later. So you should start at the innermost part of this right here, and it's going to require your knowledge of trig identities. If you haven't seen it, I have a speed trig calculation video. I recommend you watch it. It's basically how to calculate trig ratios quickly and convert radians and all that really fast and get used to it. It is not mandatory on an AMC 10. The level of difficulty of this test is like between AMC 10, 12, and AME, something like that. It's not multiple choice, as you can see. But it's good. This can actually help you. Trig can help you on the AMC 10, even though it's currently not required. So, what is this? Well, I have a mnemonic device, if you don't know that word. Someday I will make a video on my mnemonic devices. 4 trig ratios or trig identities so that you can recall the information quickly. For me, for this one, this is a sum and difference formula. And I look at the first letters here in my mnemonic device. One of them is SCCS, like maybe USC Computer Science. Who knows? You could think of something like that. But this is for sine, cosine, cosine, sine. And that means it's going to be the sine sum and difference formula. And I'm going to call it the sine of A. And then I have another mnemonic device for the sine sum and difference formulas. And that is same sign, right? So same sign, but what I actually mean is sine, right? Because the sine has the same sign. And cosine doesn't, otherwise this wouldn't be a good mnemonic device because they would both have the same sign. What I mean is, this is a minus sign in between the sine and cosine, and then this is the same sign, right? And so that's how I recall that information. This right here, if you actually wrote what it is, I want to see it more clearly because this is a shorthand notation, it's going to be sine of A cos of B. And again, the A and B are in the same order they appear right here. And then it's going to be the same sign, and then cos of A sine of B, and you will notice the A and B are in the same order they were here, left to right. Okay, so SCCS, plug in for the S gets the A, the B goes to the C, and the C gets the A, and the S gets the B. The other mnemonic device I have for cosine, which I'll just mention, cos of A minus B, it's obviously not the same sign, but my mnemonic device for that is crazy cousins, silly sisters. In other words, it's cosine, cosine, sine, sine, but not the same sign in between. And it would be the cos of A, cos of B, sine of A, sine of B. Okay? And if you change this to a plus, it just changes that to a minus, and vice versa here. If I change this to a plus, it changes this to a plus because it's the same sign. Okay, so now that we have that out of the way, how I recall and look at this and recall the information, I kind of think of degrees like my native tongue. And I learned radians like a second language, but secretly, even probably not the best, I always convert it to degrees in my mind, or I most of the time do, because that's what I started with, and it feels more comfortable, even though it's maybe weak. That's okay. So this is going to be 30 and 15, and so this is going to be 30 and 15. What I really have here is the sine of 15, which as we know is pi over 12. You can convert it, to convert pi over 12 to degrees, you would multiply by 180 over pi. The pi's cancel, it becomes 15 degrees. So if that's pi over 12, then basically this is cos of pi over 6, sine of pi over, this right here is the sine, this whole expression is the sine of pi over 12, which means, I wish I had a different colored pen right now, this part and this angle, this whole thing right here, is actually the exact same thing as that one. Because this part is the same, the cos of pi over 6 matches the cos of pi over 6, and everything in this rectangle is the sine of 15, which we can say is the sine of pi over 12. And since this times cos of pi over 6 looks just like this, sine of pi over 12, it's the same thing. If you're not sure, write it. Erase the rectangle and put sine of pi over 12, and you will realize it now looks just like this. And you're going to do it again, and you're again going to get the sine of 15. And look, there's the cos of pi over 6 that was here, so you again get the sine of 15 right here. And then lastly, this expression will be ultimately the same as it was to begin with. It's just the sine of 15 degrees, or pi over 12 if you prefer your radians. Judgmental much? Okay, anyways, so I'm going to use 15 because I like it better. And we're going to do one of two things. We need to use the sum and difference formula again. I'm going to target 45 minus 30. You can also do 60 minus 45, and you might be wondering right now, what if you had targeted that? And we'll look at that in a second. Let's do sine of 45 minus 30. Again, it's going to be sine of 45 cos of 30. The sine of 45 is root 2 over 2. The cos of 30 is root 3 over 2. Minus, then you're going to have the cos of 45, which is the same as the sine of 45. That's going to be root 2 over 2. And the sine of 30, which is going to be 1/2. Again, if you want to know how to get these quickly, watch the speed trig calculations, speed rate, I don't know, trig, speed, I don't know, something about trig and speed. I forget the title of the video. Maybe I'll link it in the description. I'll do that, I guess, for you guys. And so you can watch that if you want. Okay, so what is this? It's root 6 over 4 minus root 2 over 4, which combined is root 6 minus root 2 over 4. Now the question is this different? Because if it's different, then we'd have two different answers, so maybe we should check it out just to be safe. The sine of 60 is root 3 over 2. The cos of 45 is root 2 over 2. So that's the same as this, just reversed order, right? And if I did then the cosine of 60, that would actually be 1/2, and the sine of 45 would be root 2 over 2. It's the same exact calculation, same exact values. So we can say that A is 6, B is 2, and C is 4, getting that from right here. And we're going to plug them into A plus 2B plus 3C. A is 6. 2B, or no, I'm not going to go there. Not 2B, right? Okay, so 4, I went there. 3 times 4 is 12. This is 10 plus 12. The answer is 22. We're on to the next problem. All right, and continuing on with the 2020 SMC Problem 13 Sacramento Math Community Contest held this past weekend. Oh, by the way, I think I forgot to mention it earlier. Happy Thanksgiving if you live in America. If you don't, well, you can still celebrate Thanksgiving. Why not? It's just a time to be thankful, right? So there's more to it than that, but we're not going to get into all of that. A 10 by 10 grid is numbered such that the entries in row I are numbered as such. And there's this crazy long list of weird looking stuff, and it kind of freaks people out a little bit when they see that kind of stuff. So what you want to do is just don't freak out. Just put a number into I. Where do you want to start at? Row 7, right? No, you started at row 1, right? So let I equal 1. Plug that in. 10 times 1 minus 1 is 0. 10 times 0 is 0 plus 1. So it would be 1, and that's row 1, so we'll put it here. The next one is 0 plus 2 plus 3. So we can see that the top row is going to go 3, 4, 5, 6, 7, 8, 9, and 10. Next up, what happens? Then what about row 2? So if we go to row 2, it would be 10 times 2 minus 1 is 1. So 10 times 1 is 10 plus 1 is 11. Oh, we get it now. It's just counting, 11 to 20 and so on. So you're going to have 21, 31, 41, 51, 61, 71, 81, and the last one will have a 91. And so is that really 10? Yes, because this is like row 1, if you will, and then the second row starts at the tens place as a 1. So the 10th row would have a 9 starting. Okay, an ant wishes to take a path from the upper left corner of the grid to the bottom right corner of the grid. Probably don't make squares for this, because if you did put a grid like this, would you start here and travel this way and then you would count 1 twice? It gets a little confusing when that happens, so don't bother with the grid, just go with the numbers. Obviously, if you had a square like X and Y kind of grid, then it would be more confusing. You probably couldn't give a satisfactory answer. So just put the numbers to the bottom right corner of the grid such that it can only move horizontally to the right or vertically to the bottom. Determine the minimum possible sum of the numbers that the uncle Oh, it's not. Oh, you're right. It's ant, right? The ant. Okay, sorry. The ant passes through. So we're going from here down to 100 somewhere over here. Okay, so the question is, basically you want to try to keep the numbers as low as possible. If you went down this way, you would be minimizing the ones place, because you'd only be using 1, 1, 1, or you're kind of minimizing it. But when you got to the bottom and went to the right, you would have all of these 90s, which is a lot of 90s. We kind of want to avoid large tens digits, like 9, for instance. So what if we just went across this way, and actually this minimizes the units digit because they're all 0. So the sum of the numbers, we're going to do from 10 to 100, which is going to be 10 times the sum from 1 to 10, correct? And the sum of the numbers from 1 to 10, that is a triangular number series, which is n times n plus 1 over 2. So 10 times 11 would be 110 over 2 is 55, times 10 would be 550. Again, if you don't know what I'm doing there, it's 1 plus 2 plus 3 plus dot 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 plus n. It is equal to n times n plus 1 over 2. These are called triangular numbers. I've mentioned it in other videos, but you can probably find even other videos online that go into more detail about it, which I'm not going to do. So the sum of the numbers from 1 to 10, 55 times 10, 550. Okay, but now we've got to go from here over to here. We're going to do the same thing, just now it's 1 to 9. So 9 times 10 is 90, divided by 2 is 45. You will add that to get 595. Now you may be wondering, what if you put row 1 at the bottom and built your way up? It would actually be a different answer. If you try it, I'll let you try it out. It comes out to 514. I was solving these last night kind of to preview the questions before I solved them today on the board, and I did this one in my head and I got this answer. And so then I checked with them, and they accepted either answer because of the ambiguity of the question. So that's going to be it, 595 or 514. We're on to number 14. Continuing on with the 2020 SMC Problem 14. Chords AB and CD are parallel chords in a circle. Well, don't go past that comma, just draw it, right? So make a circle. Something like that. It's kind of drawn from the side. Maybe it's not perfect. So we've got AB and CD, and ABCD is a rectangle. So I'm just going to go up here and make a chord going across, and we'll come straight down here, hit the circle, go over, and up to here. Okay, so this will be AB and CD because it says ABCD, so you have to go in that order around the outside. Okay, chord F intersects AB and CD, so it's going to hit AB and CD at G and H respectively. I just put them kind of near where they're going to go. I don't put them quite where they're going to be exactly yet because we don't know. Again, respectively means that they show no, they don't. No, it means that G goes with AB and H goes with CD. So 1, 2, 1, 2. Same order, in other words. Given that DH is 8 and then HC is 2, skipping over this part. So if it's 8 to 2, it's probably, right around there or so. So this would be kind of where H would be. And this would be 8 and this would be 2. Okay, so we've got the 8 and 2, but HF is 1. Again, F is the letter on the chord EF. So we're probably passing through like this. And so F would be here. I'm going to assume that we're going to go kind of like that. And E will be up here. And then G would be this point right here. Okay, so angle GHC is 120. If I look at GHC, it looks pretty close to 120. You might have to adjust it over, but it's not worth redrawing the diagram for. It's pretty close to 120. The length of BC, let's underline this so we don't lose it later. The length of BC, that's the other side over here, can be expressed as m root n. Again, all the common ending for that situation. We can read it later when we get the value of what we're looking for. So we're looking for the length of BC, which again is the side over here. So how do we attack this? We've got that this length is 1. Okay. It looks like it's going to be power of a point. And the reason is we have a chord going here and one going here. And we know what this length is, 1, and we know that's 8 and 2. We basically want this length here. I don't know how it helps us yet, right? Because we're looking for BC. How does finding EH help? Don't ask that question. We'll kind of ask it, but set it aside for now. When you don't know what to do in a problem, explore, find new information, and then figure out how that new information might help you. Keep in mind, we still haven't attacked the 120-degree angle concept yet. So power of a point works like this. If you don't know, there's several things that you have. It would be A times B equals C times D. So A times B equals C times D. That's power of a point for chords inside of a circle. And so it'll be x times 1, which is x, equals 16. So now we know that EH equals 16. Okay, so we've got that. We're still kind of stuck. Let's kind of look around a little bit. If this is 120, this would be 60 right here. Because this is, these are alternate interior angles. So because of the parallel lines. So they're going to be equal. 120 would be right here. But we want the BC. We could target the AD since it's the same length, but I think I'll just look around over here. Let me erase this 2 so I can see. If I make this 120, then this would be 60. The fact that that's a 60-degree angle, and I've got a 90 up here even, 90, 60, where's the 30? Well, it's not currently in existence, but we can fix that. We just need to extend the side, right? So we're just going to keep going out this way until we intersect a point down here. Okay, so we know that this length right here, HC, is 2, was given in the original part. We know that this is 90, and this is 60, and this is 30. So I can basically say, if this angle is 30, okay, again, 30, 60, 90 is as easy as 1, 2, 3. In other words, 1, 2, and root 3. It'll be 1x, 2x, and x root 3. 2x being the hypotenuse. So 1x is the side opposite 30, then the side opposite 60 would be x root 3. And since the side opposite 30 is 2, we would know, we can call this, I don't know, k, for no apparent reason. Then ck would be 2 root 3, because it's the side opposite the 60-degree angle right here. Okay, so once again, we're looking for BC, which I'm going to make it as a new x value. We'll get rid of this one. This will be the x now. I like to reuse x if I can. It's the best variable. I don't know. Fight me. Okay, so the x is going to be the best variable. We're going to use that right there. How are we going to do that? We're going to use power of a point again. But this time, it's a slightly different setup. Let's cover it real quick. You're going to have a point outside the circle here, and we're going to come through here. And the way that I remember this is it's part outside times whole. So if this is A and this is B and this is C and D. So the part outside of the circle is A and the whole thing is A plus B. So it would be for this one A times A plus B. And the way I memorize it is part outside times whole equals part outside times whole. So then that would be equals C times C plus D. And maybe we can use that here because we do want BC, which would be like the B right here, okay? So if we tried that out, the part outside is 2 root 3. So you would have, let's go over here and write it, 2 root 3, that's the part outside, times the whole, which is BK, it's going to be 2 root 3 plus BC, which we're calling x. So x plus 2 root 3. Okay, then part outside times whole equals part outside times whole. And so we don't need that h anymore. It was a placeholder. So this right here is going to be, that's the 2x and the easy as 1, 2, 3. So if this was 2, this is going to be 4. Yeah, so that's 4 right there. And then since that's 4, we want the part outside of it. Keep in mind, why did they tell us this was 1? 4 is not the part outside. 4 is the hypotenuse of this right triangle. So the fact that this is 1 tells us that the part outside is 3. Be careful not to make that mistake. Now we want times the whole. So again, we had EF. What the F? EF. What the EF? It's kind of pronounced F, kind of. All right, so what is the value of EF in this case? So it's going to be 16 to here, as we found, EH is 16 plus the 1 is 17. And then the part outside is still 3, so 3 plus 17 is going to be 20. We could divide by 2 root 3 now, but I like this combo, so I'm just going to distribute. You're going to get 12 plus x times 2 root 3. Again, 2 times 2 is 4. The root 3's make a 3. 4 times 3 is 12. Equals 60. Subtract 12 to get 48. Divide by 2 root 3. That will be 24 over root 3 because the 2 divided into 48. Again, using the trick we talked about earlier in this video, 3 goes into 24 8 times, and you're just going to attach a root 3 next to it. The answer is going to be 8 root 3. It's not the actual final answer, but it's the answer that we want right now. It's the length of BC. And look, it's expressed just as they said. Let's quickly verify m and n are positive integers. Got that. N is not divisible by the square of any prime. That's going to be the 3. It is not divisible. Basically, it can't simplify, right? What is m plus n? 8 plus 3, 11. We are on to the last problem of this set. This is probably my favorite one of this 5-problem set. I kind of like the design. Well done. All right, the last problem of the this set that I'm doing for the SMC, the 2020 SMC. Again, it's a mock test made by the Sacramento Math Community Discord server. Link in the description. Problem 15. Compute the value of this plus this. Okay, so how do we attack this? My first thought, I'm going to go in the order that I solved the problem in. My first thought is, this is kind of like if I was to divide this by 2, it would be basically the sum of the numbers from 1 to 3. Because if you didn't know, 1 plus 2 plus 3, actually let's just go, we'll keep going. If I went plus ... plus n, it would equal n times n plus 1 over 2. So my first thought was, what if I divided all of these by 2? Let's say I set this equal to a, which I'm calling the answer, and I divided both sides by 2. Then what I would essentially have is the sum of the numbers from 1 to 1, and then the sum of the numbers from 1 to 2, 1 to 3, all the way down. They're called triangular numbers. Again, real quick, why are they called that? If I have 1 dot, there's no triangle. Get over it. If I have 2 more dots, though, this would be 1 and 2, you can now see a triangle form. And if I have 3 dots added to that, that's 3 dots. 1 plus 2 plus 3, 6 is called a triangular number because the 6 dots can be made into a triangle like that. So again, it has this sum, n times n plus 1 over 2. So it's basically the sum of the first 100 triangular numbers. Okay, so now that we realize that, I kind of thought, how are we going to do that? I would have a bunch of these running around, and then it kind of hit me. What if we just called each of them this, right? Then this would be almost a summation, right? If I just multiplied back again by 2 to get back to a again, to get rid of that division by 2, then basically this is n times n plus 1 for the first term of a series. And this is n times n plus 1, right? So this could be a sub 1, a sub 2, a sub 3, and you can see that 2 is this number, which means that a sub n is simply n times n plus 1. So again, the way that I realized that this is what it was by thinking about triangular numbers and recognizing the consecutive digit or a consecutive integer multiplication was part of this. But then I decided I don't really want that to. I'd rather just have it like this. It becomes a summation. This is a capital sigma. The lowercase sigma looks like this. They're both Greek letters. And usually the lowercase sigma is used for standard deviation. The uppercase sigma is used for summations. So we're going to start at n equals 1 to 100. That's where we're going to go, okay? Because those are our terms, and we're going to have n times n plus 1. Okay, how are we going to do that? Well, sometimes you just have to kind of take another step, like peek around a corner to see what it looks like. What if I made another one and I went from n equals 1 to 100, but I just wanted to look at it different. I'm going to distribute this. Again, just to get a look around the corner. It's going to be n squared plus n, but you might not know it. You don't work with sigmas a lot if you haven't finished Algebra 2 yet or studied it on your own. You can split this into two different sigmas. So this is going to be equal to the summation from n equals 1 to 100. If you don't understand how summations work, I'm not going to break it down in this video. I bet Khan Academy has one where they thoroughly explain them. I highly recommend you watch it. They can be very powerful tools. N squared, I can split it into two summations, both from 1 to 100. Okay? Now what? That's just one of the rules that you can do with summations. This one is just the sum of the numbers 1 to 100, which, as we said earlier, is n times n plus 1 over 2. So it's going to be 100 times 101 over 2. That cancels to make 50. 5 times 101 is 505. And then throw the 0 on the end, it's 5050. This is also the famous Carl Friedrich Gauss problem where he supposedly solved this problem when he was in like 4th grade or 5th grade or something. A genius person, now deceased because old people die. He's like from the 1800s or something. I don't know. Anyways, he did this whole problem in like 5th grade and did it in like 10 seconds. And rumor has it, or legend has it, that when he was finished solving it, because the teacher assigned it to the class, they had little chalkboard slates or whatever they used back then, and she thought it would take them, a long time to calculate the sum of the numbers 1 to 100. Well, Gauss figured it out. He didn't really use summation notation, but he paired 1 with 100 and 2 with 99 and 3 with 98 to make a bunch of 101s. There was 50 of those. 50 pairs of 101 became 5050. Supposedly, as legend has it, something along the lines of he threw it on her desk and said, "There it lies," all dramatic. Yeah, well, anyways, that's the story. So 5050, what about this one? If you pull out a pre-calc book and you look up the sequences and series chapter, you will probably find one for this. It would be worth it if you added this to your small notebook. This is simply going to be n times n plus 1 times 2n plus 1 over 6. It's a little complicated. How do you memorize that? Well, it's hard. You put it in a small notebook and you review it once a week, and especially the week of the test, you review that small notebook every day, and eventually you too can recall random formulas that you often don't use. And so then n squared. So this is the value though. We're going from n equals 1 to 100. It's the 100 that goes in here. Basically, this formula is actually 1 plus 1 squared plus 2 squared plus 3 squared plus ... plus n squared, right? And so the n being basically the last thing that you plug in. It's kind of confusing because I used 1 here. N equals 1 and that's n squared. But 100 is the last value you plug into this sigma. So it's the sum of the first 100 perfect squares. Let's plug it in. We've got 100 times 101 times 201 over 6. I'm going to write that as 2 times 3. Why did I write it as 2 times 3? Because I've seen the future. And 201 is divisible by 3, and it's not divisible by 2, and I want to split these, divide them in. 2 is going to go into here 50 times. Look, it's the same calculation that we had over there. 3 is going to go into here 67 times. You now have 67 times 5050 plus 5050. That will be ultimately 68 times 5050. Now I'm going to take that 0 off and say times 10. I'm going to multiply these two numbers by hand. 505 and 68. 8 times 5 is 40. 0, 4. 8 times 0 is 0 plus 4 is 4. Again, you get another 40. Put a 0. 6 is going to be 30, 0, 3. Why 3? Because there's nothing to add to it, because 6 times 0, you would have a carryover of 3 from the 6 times 5, and you're going to do it all over again. 6 times 5 is 30. You will add this up, 0, 4, 3, 4, 3, and then don't forget the times 10 on the end. It's not quite like the AIME, because the AIME only has 4 spaces that you can put digits in. The answer for this problem is 343 400. That is the end for this video. I will see you guys sometime later, maybe tomorrow, maybe Saturday, maybe Sunday. We'll see what happens. Who knows? Enjoy the rest of your night.